Hi, my name is Ahmad Zulhilmi bin Ahamad Pauzi. I am the student of Mechanical Engineering for the subject Microprocessor. So this is the 4-bit adder with 4-bit register and 7-segment display, which is my lab test for the microprocessor. So first of all, I would like to thank to Dr. Lim Kim Chuan as our lecturer. So we go through the circuit. So this is the overall of my circuit, which is they have a clock, 4-bit adder. There is the register, which is logic gate and the flip-flop, and the last one is segment display. Okay, we will jump to the full 4-bit adder. This is the 4-bit adder chipset, which is 74HC283. So when this is the input of the input A, and this is input B. Okay, so how the function is when we are giving any binary number from A and B, the 4-bit adder will perform operation of addition, which is input A plus input B. So this is the output of the adder itself. So we can try, which is 001 plus 0001. So the answer will be 10, which is 2 in decimal number. So this is the circuit itself. So this is so I use this circuit from the lab sheet lab 4, so easier to explain how the adder function. So when we are in this case, I am performing 1 plus 1. So but this is S in this we label this is S and this is the C out. So the S is not light up, but the C out is light up because there is no sum here, but the C out will come out the 1 as 1. So the C out will carry out the number, which is the 1, into the next adder, which is where the C in input. So this is the I am not constructing the 4-bit adder using this circuit because this is a logic gate. So this is directly 4-bit adder. Okay, this is more example of the addition operation of the 4-bit adder. So this is how the function it gets from the adder. This is output of the adder. So this is not light up because this is carry out. So if we are constructing the 8-bit adder, so the next this carry out will go to the C in. So here the carry in to perform the next addition of the binary number. So by the way, we are using the 4-bit binary number only. So this is the output of the adder. So we set into okay, we move to the logic gate, which is to help data to be stored into the D type flip-flop. This is the 4-bit type flip-flop. So this is the D flip-flop, which is we are using 4 of them. So this is the OR gate, this is the AND gate. We are using 2 set of AND gate in here, and we are using 1 set of head inverter. So I already get the circuit from the band item. So I draw in my paper, so I convert it to the PDF. So this is the overall of the this is 1-bit register, so easier to explain. So this is the circuit block diagram of the 1-bit register. So how its function itself, this when we are using load, okay, load and data for 1-bit register. Okay, when load is low or 0, we call the register will store the previous data. They are not accepting a new input data. So we can see here is when load is low, the register will not accept any data from the input data here. You can see Y is the new data, X is the current data. So we can see here there is Y. There is no Y go here because N, the truth table of N, anything multiply with 0 will get the 0. Okay, when we want to put the data in the register, we have to hide the load. We have to set the load to hide or 1. Okay, you can see here there is no more X because when the load is 1, so the data giving Y, anything that multiply with 1 will get the Y. So we can see here the Y start looping in the circuit, which is the resistor. So that is how it works. So we are using the 4-bit register, which is we have to copy this circuit into the 4. So we can see here, okay, there is no data in the register itself. Okay, we can see there is no data will come into the register because this is the output. This is the output of the adder. We want to put in the data, so the line from here will go into the input of the register, but the register is not accepting any input data unless we are set load to high. When we set load to high, the register will accept the data when the clock is rising. You can see here there is 4-bit binary number is same over here. You can see the output of the adder is same to in the register. When we load the load, set load to the low, if we put any we are giving any input to the register, so there is nothing will go into the register because the load is low. So the register will keep this data. You can see here. Okay, so when we want to accept new data, so we have to set load into high. Okay, we can see over there we are loading the new data from the adder, output of the adder. So we can see here this is the 7-segment display. So what is the function of the 7-segment display itself? Because so it want to show the number from the binary to the decimal number, so more easier, but we have to convert the binary number into the suitable input for the 7-segment display. So that's why we are using the 7-segment decoder. So there is the input 1 until 4, and the output A, B, C, D, E, F, G. So same. So we can see here there is this letter same letter in the 7-segment display and 7-segment decoder. So we can see here this is the full lab test circuit from me. So we can change any data. So this is load is on high, so the data will accept new so the register accepting new data from the 4-bit adder. So they are showing the 7, which is the binary number is 0111. Okay, so the 7-segment display show is 7. So that is for me. Thank you for watching.